Welcome back to our introductory series on using Lyra. This is chapter 4, where we're going to be discussing the climate systems and the landscape materials associated with the climate systems. So in our first 3 videos, we talked through the organizational structures and using gameplay features as the foundation of how we were restructuring our program. In chapter 2, we did a quick overview of enabling Epic online services. Chapter 3, we added some weapons. And now in chapter 4, we're starting into our next plugin, which is our climate systems in the landscape. So onto the climate systems. So this was largely crafted pre-Lyra. Many of the classes I was able to port over into the plugin and then adjust with sort of minor modifications. So some of the code is probably going to be optimized over the coming months, and then I will post any material changes to the structure as I learn more. But as it sits right now, here's the overview of the system. So as I said in our previous videos, we're trying to modularize and put into gameplay features each of the major systems to keep them isolated from the other systems and able to manage the project better. For the climate, there are 4 primary classes. The climate manager, which is a singleton class that is added to the level and manages all of the climate aspects, such as the day-night cycle, the weather effects, the wind, etc. So each level will get a climate manager loaded into it, and then it kicks off the process. Maps can then be divided into zones. So a climate zone is basically an overlap trigger. When a player triggers a new climate zone, the climate manager will start to transition from one climate to another for that player. The climate component is added to the player character, and its primary job is to use player-related effects, such as particle systems and sound effects, that really are just isolated around the player and only seen by the player, not other players, as they create an effect of being either in the rain or in another climate environment. Finally, there's a climate-aware actor, which is just an actor, an empty shell blueprint that will trigger and respond to various climate events. The example I'm using will be a fire that turns on at night, then turns off in the morning, so that the fire is only running during the dark hours. So those are the 4 main classes. They are largely constructed in C++. That's the way I had them in the previous project, and I didn't feel like tearing that all apart and making it again in Blueprint. So we'll walk through some of that in a few minutes. So let's go to the main class, the Climate Manager. The Climate Manager is set up with 2 primary components. The day parts, which I've got set up as 4 different parts. They trigger at dawn, noon, dusk, and then midnight. And I found that those 4 trigger points were sufficient enough to trigger any in-game effects that you may want to have, such as birds waking up at dawn, sort of high noon events as the environment gets dark around dusk, and then finally at midnight when you're transitioning into your night cycle. We can always add more, but 4 seem to work for me. Then there's the concept of weather patterns. Each weather pattern is set up in the manager and uses a series of assets to create the illusion of that weather pattern. Everything from sort of a normal sunny day through various changes in rain and snow, and we'll show some of those in a minute. For the climate manager to function, there are a couple of actors that it looks for in the scene. It'll look for a directional light, which will be your sun. That's so that it can move the sun and rotate it around as part of the day-night cycle. It'll look for volumetric clouds so that we can change the opacity on the clouds for stormy situations where we want the sky to be more overcast. It'll look for the exponential height fog so that we can vary the level of ground fog. The skylight and the atmosphere, again, mostly for reflections and other aspects like that. And then there's a material collection that's used to populate the overall wetness of the ground, the overall wind direction and wind speed, which are then used in materials to adjust the rest of the world. There were some things that we put in from a performance perspective. So not everything is running on every frame. The first thing we did is turned tick down to 1/10 of a second. So it doesn't need to tick away nearly as frequently as some other actors might in the game, because you're talking about longer cycles where things aren't changing nearly as frequently. Then we have a standard event that fires off right now every second. That will do some of the lighter environmental adjustments. Then we have one called expensive, which fires off every 2 seconds, and that does a little more heavily computated oriented code. And then very expensive, which is currently running every 4 seconds. So there's some performance tuning that can be adjusted and tweaked within the climate manager, and as well as any of the features can be turned on and off. So on the right-hand side of the screen, you see that there's some checkbox for turning on and off elements. Those are good for debugging, checking what things are going on. You'll see our initial weather pattern, and then some other stats of when things occur throughout the day. So that core actor is the driver of the entire system, and we'll spend some time looking at it in game. The next thing to understand is that the structure of the system is all about curve assets. Most of the elements in here, whether it be how opaque the clouds are, or how fast the wind is moving, or how dense the fog is managed through a series of curves. Most of those curves have been scaled to a 24-hour. So the curves are running from 0 to 24 to represent the hour in the day, and then it just loops around and repeats from that point. So the curve files are where we can vary the various aspects of the individual climate systems, and then they get applied whenever a climate change event occurs. So as an example, if we look at a sort of breezy day cloudy day, you'll see across the top a 24-hour period. So the line is roughly from 0 to 20. Not much is needed in the dark. So, the 0 and the plus 20 to 24 is all considered early morning, and that doesn't require, there's not a lot of light, so you can't see much anything. So most of it occurs in the cloud opacity building towards 5 a.m. Then it's kind of peaking around 5 a.m. Then the cloud opacity is coming down till around 10 a.m. Then it's rising to 15, which would be 3 o'clock in the afternoon. And then cloud opacity starts to dissipate from there downward through the evening. So that's kind of an example of some of the curves. All the curves are tweakable and adjustable to get the visual effects that you're looking for. The other thing that is important to understand is that the climates don't exist. The climates only exist on the client. And this was a big change as I moved into Lyra, that I had to re-architect some of the way I was running the climate system before. So what you're going to see here in a second is an example where I've got I'm toggling back and forth between two clients. So the weather effects are going to be either in the snow or in the rain. And you'll note as I toggle back and forth between one client and the other that you don't see both effects. So the character that's in the rain only sees rain, and the character that's in the snow only sees snow. Now, normally you wouldn't have these two zones this close to each other, but for testing purposes, it works out. So let me try to run this video. I was running out of bandwidth earlier. So here you see on one client's perspective, I'm in the rain, the ground is wet, the trees are blowing, and if I leave, it will start to dry up, the trees will stabilize, the ground will start to lose its wetness and start to return back to a more normal texture. And if I go back, I think I'm going to go back. I go back into the zone, the rain starts to pick up, the ground starts to get damper and damper until it gets fully saturated. If I flip over to the other character, you'll see the other character is actually in snow biome. where the ground isn't quite as wet. There's sort of particle effects, and they're just popped out of it, and now he's in the rain environment, just like the other character. What you would normally see. We leave that biome. We move back into the snow biome. And you can see the snow effects around this character. And then if you look subtly, I toggle back and forth, there's no sign of snow over there where the other character is. It all looks like rain. So when this client is running, it's in the rain, unless he moves out of the rain and into a more normal environment, or if they move from the normal environment into the snow environment. So just an example of how that's working, just showing that it's actually on the client, not the server. Okay, so the next thing to think about is the climate aware actors, and I'm going to go in and show you how these work live in the system. But for the climate aware actors, they respond to these various events that are triggered by the climate manager that will then be up to the blueprint scripting to determine what you want to do. So in some cases, I'll have lights come on or go off. In some cases, you can trigger sound effects like cicadas at night. Anything you really need to do is just drop a climate aware actor into the level, wire it up the way you want, and you're good to go. On the ground wetness and the trees, those were done using a material collection, parameter collection group. So the wetness is based on a function that takes the wetness factor that the climate manager is setting and determines basically how porous a surface is and applies wetness to that surface. So the rocks will get wet different speed than the dirt in the ground, and the grass will get wet. So a wetness is applied. It takes a variant on the base color, specular, and roughness to make the wetness effect. And then the wind is basically on world position offset. So there's a couple of embedded functions where we take the overall stiffness of the tree, which is just a factor to determine that big trees shouldn't sway as much as thin trees. So there's an adjustment factor you can do by tree that will give you a different sway. Then that's fed into a function that ultimately determines what world position offset there needs to be. So with that as a background, let's jump in. So I'm going to go first. I don't even have it running. Okay, first we're going to go to code. So as I said, most of this was done in the C++ routines. You'll see the basic actors that we just talked through are available here. I won't spend a lot of time on them here. We'll take them in game for a minute. But starting with an actual climate zone, the zone basically defines a collision box that reacts to the collision channels that are necessary, and then binds the begin and end overlap events. Once we have an overlap, one of the important elements is we need to make sure what we're overlapping with. So in this case, we're first checking to see if it was a character. If it was a character, that's great. I want to see if it had a controller. If it had a controller, great. And then is it locally controlled? These are the checks that say, okay, the actor that just overlapped with this zone is the controlling actor of this area. So I put here, I'm in my world. What it then does is it goes and finds the climate component, find component by class, gets the component, and then changes the weather to whatever weather type this particular zone has. So the zone is very simple. Basically, when you overlap, if you're the right character, you trigger a change in the weather for your client. On the ending of the overlap, same checks to make sure I'm the right person, that I'm on my world. I still go get my component. There's just a slightly different component here, which is as I exit one zone, I may be inside of a larger zone. And so there's this notion of being inside nested zones. So think of a bigger zone being light raining, and then in the middle of that, you have a zone which has heavy rain. So as you exit heavy rain, you want to go back to light rain. So we do a quick overlap check of all the climate zones, and then grab the next one and set our zone back to that. And then eventually we will fall back to normal if we're in no zones at all. So the climate zone is fairly simple. The component is actually quite simple too. So the component basically binds and listens for the weather change event. So whenever a weather change occurs from the climate manager, this event will get triggered on the component, and which is the weather change occurred. We will do whatever we need to do. We have an override if the blueprint needs to do anything further, and then we'll change any active effects, such as, which are largely just the sound effects and the particle effects. And so we'll see that in game, but basically everything down below is just either turning on or off sound and or particle systems. The climate aware actor is even more simple. So it's listening for day parts and it's listening for weather changes. And basically it just has one pass-through function that says, hey, is it daytime? And this is just a quick check to say if I'm in the daytime or nighttime, I may want to initialize slightly differently, which we'll see in the editor. So with that, compile. Just launch. Sorry about that. I thought I had that open. So once we're in, I'm going to open up that test map and start to sort of navigate through some of the blueprints and components in the system, show you some of the ways you can tweak and adjust it, what I found to be the best way anyway. Almost there. Okay, so this is the test map that I just showed the video for. And I zoom out a little bit. We've got the two climate zones, one for rain, which is over here, one for snow, which was over here. We have our climate manager, which is, again, just a simple actor in the level. We have our fire, which is a climate aware actor. Our campfire is, and like I said, the campfire is quite simple. It's just listening to the events from the manager and firing them off. And we go from there. So let's take a quick look at the manager. So the manager has a variety of flags just to check on and off whether we're testing something. Where do we want to start? Typically, I'm starting in normal. How frequently I want to run each of the routines. So the first three say 1 second, 2 seconds, and 4 seconds. The transition duration is for my lerps. As I lerp from one environment to another, you can either be more abrupt or you can be slower. Special one for the wetness transition, because ground will dry out slower than the basically wind dying out or other aspects. The time of day parameters that I found most useful is you would normally have your seconds per day quite high, maybe 700 to 1,000 seconds for a day cycle. Here I'm cycling day-night in 60 seconds. That's mostly for testing. And I'm triggering my dawn, noon, dusk, and dark at 0, 25%, 55, and 70% of the way through my day-night cycle. You can tweak those to match your overall aesthetics and the way things work. And then I have a variety of patterns. So let's close those all up. So these are the weather patterns that we've set up. And probably the easiest one to look at might be light rain. So when light rain is triggered, an ambient sound is played on the player, and a weather particle system is played. There can be multiple. It's just an array. So light rain, the particle system light rain is played. It's played above the player with a downward velocity of 500. And it's welded to the player so that when the player moves, the particle system moves with it as opposed to just being stationary. You can delay activation of a system or deactivation of a system. The cloud color basically changes the color of the clouds. So when rain comes in, the clouds are darker. When it's sunny, the clouds are lighter. Our cloud opacity curve for raining, basically, as I was talking earlier, all of these curves would be slightly different. So if I wanted to have my cloud opacity, the shape looks similar, but it's starting at 6 and going to 6 1/4. Whereas if I was in maybe stormy, I'm starting at 9 and going up to almost 10. All right. So basically the adjustments of these points will allow you to change how any given environment looks and feels. So I just found playing around with the settings to be the easiest possible way. So each of those: cloud opacity, cloud speed, fog density, wind direction, wind speed, and then what's my target wetness of the ground, 100 or 1 being completely saturated. So for example, I won't go above 0.8 in a light rain, but in a heavy rain, I'll go all the way to 1. So basic settings on the manager. That way when you play, I'm going to see some of them in action. So we've got our day-night cycle moving at a fairly good clip. We'll see the shadows are moving across. We'll get a full day in 60 seconds. We'll look up and see our sun's up there somewhere. There's our sun. Sun's going to set. As our sun sets, oops, I went into the snow. As the sun sets, you'll see these 2 campfires light up slightly different on the randoming. Each actor has a slight random variation so that all the campfires don't light up at the exact same time. I find it more reasonable to say, okay, there's a bit of an offset, and therefore they don't happen at the identical time. So those 2 actors fired up at dusk, and then they will turn off at dawn. You'll see the height fog changing slightly there in the distance. As the day gets brighter, the fire lights go out. The sun is rising. It's moving through its apex. So at the apex, you see very little height fog in the distance. And then, oops. And then it crashed. Okay, we're back from a crash. I thought I would do is take a few seconds to talk about the swaying trees. The 2 trees are swaying slightly different so that when you have multiple trees in an area, they're exaggerated right now because I was testing, that they're not going to sway exactly the same. And they also are now leaning towards me because the wind direction has shifted. So as the wind direction shifts around, the trees sway in different directions. And you'll notice that the ground is quite dark and saturated. So as I move out of the rain, it will slow, the trees will stabilize back up to center, and the ground will start to dry up as it gets lighter and lighter. Same with the rock, and eventually you're going to get to a fully dried out environment. So let's take a look at how those material functions are working. The heart of the trees and wetness is in, where did I put this thing? All right, there's another way to find it. Left it there. Oh, there it is. So basically, material parameter settings, many of these are from different assets, but the wind speed, some dampening on grass blades so that the grass blades don't go crazy. There's our wetness setting, and then we have some things that will puddle. So if we have shallow water, puddles will form up on those shallow pools of water, all being done through material functions that reference this climate parameter setting, which are updated on. Here. So here in that material collection, the various parameters are set from the manager as being our wetness, raining, and puddles, which is this collection, which then gets used in the assets. So for rocks and trees and anything that's in the environment, the wetness is picked up from the climate parameters. We calculate based on roughness and metallic how porous the surface is, and then we apply wetness, which basically says, okay, take whatever base color you had. We're going to do some desaturation and saturation of that to darken the color. We make some adjustments to that. We take our porous factor and we work that into the equation as well. Then down here, we take our input roughness and we append our specular value to it. We weight some constants in LERP based on our wetness mask. So depending on how wet we are, we'll go from light to dark, mask those and send them out as roughness and specular. So the wetness is actually fairly simple from a function perspective. That's the rock. The rocks don't sway. However, if I go to a tree, so the tree has the same wetness routine in it, so that the bark of the tree can appear wet as the rain falls. But down here, you'll see that it also has a world position offset where we're taking in a parameter we've set is how stiff of a tree this is. So whether it's a pine or an oak, you're going to get different stiffnesses, how much sway you allow this tree to have before you cut it off. And then this is basically a pass-through function. So we run those into this bend tree function, which is where all the magic occurs. So let's start with, if the wind is less than 10 kilometers, then we rustle the leaves. So this basically just says when the wind is low, the tree leaves should rustle a little bit. But once wind picks up to about 30 kilometers an hour, then the rustling should stop because we're in full-blown swaying mode. So that's the rustling of the leaves. Then from down here is the main tree logic. So we take the overall stiffness that we defined on the tree, we run it through and add sway based on wind direction and wind speed. We keep sway out of the equation until we hit 20. And then we kind of multiply it back up to get a little more thing. Here's some dampening factors that we can apply to dampen it. And then this branch says a couple of things, which says I've kind of locked sway at 100 as kind of the normal sway, and anything less than 100 is less sway, and anything more than 100 is more sway. So this just sort of clamps that and allows you to get some fine tuning on that. And then this introduces a little bit of randomness so that not all trees are swaying in unison. So it basically takes wherever it is in the world and uses that as an offset to say, okay, the tree can sway a little bit differently. So those all feed in. And then basically whether or not we're adding our leaf rustle or not, and then that outputs back into the world position offset. So those two material functions are largely in every material that's in the plugin. So the Climate Core plugin, any of the assets that need to be either wet or swaying in the wind, those assets, including the landscape, the grass, the trees, the rocks, are all self-contained within this one plugin. The plugin is quite simple in that the only thing it does is it adds a component. So we seek the Lyra character and add the climate component to the Lyra character, and we only add it on the client. So we don't add it on the server, we add it only on the client. So when that plugin is activated, the component is added to the character. The manager is added into the level. So in the level, you have the climate manager, any zones that your characters will run through, your exponential height fog, your atmosphere, your light, your sun and moon. So by having your sun and moon two directional lights, this is an interesting trick. So let's go with, of course I override this in the code, but so you can have a sun that might have 3.5 as its intensity and a moon that has 0.5. So the moon doesn't give off as much light as the sun gives off. By attaching them at 180 degrees offset, when the sun goes down, the moon goes up. So the sun is rotating around, and by very nature, when the sun goes down below, the moon comes back up, and that gives you some night ambient lighting, so you don't go completely pitch black. You can vary, obviously, the intensity of the moon and coloring, etc., but that gives you an effect of not going 100% to dark. All right, so that's a bit of an overview on the climate system. And next, we're going to dive into the item system. And with any of these, if people want more details, want me to dive deeper into any of the components, I know I'm going through these fairly quickly. But if you do, leave a comment or a like, send a note, and we can always record something a little more in depth into a specific topic. Once again, thanks for watching, and sorry about the crash, but it happens. Take care.